My name is John Keswick. I'm the co-founder of eFunctional Safety, which is a small consulting firm providing services for the process industry sector predominantly. There's a bit about my background on the left-hand side there. You can see I've spent pretty much my whole career in the automation field. When I look back, starting with Schneider, that was pretty much product management and product based. Moved on to a systems organization called More Products, which doesn't exist anymore, but there I was critical systems manager. And we had a team of people who built and engineered systems, safety related systems and control systems for power generation, floating production vessels and various different applications in the chemicals and pharmaceutical sector. Siemens took over More Products in around about 2000, and I was promoted to the leader of the Global Process Safety Initiative and spent a number of years there building teams globally. In 2004, I joined Exeter as a partner and spent nearly 10 years doing functional safety consulting and teaching the CFSE program, of which I am one myself. That stands for Certified Functional Safety Expert. And then in 2013, I set up my own company. I'm not going to spend all day talking about myself, but obviously it's difficult to get the feedback from everybody else. So one thing I can show you that I'm working on at the moment is those things on the right-hand side. I'm a functional safety assessment leader for a biomass conversion project at the moment. I'm leading control HAZOP, or control and safety system HAZOP on a new control and safety system on a plant. I'm an FSA leader, functional safety assessment, again, leader for a chemical plant, SIS upgrade. And in my spare time, I co-author e-learning courses in this field. A very quick advert for the company, just one slide. This is what my company does, provides consulting in the field of functional safety predominantly, but that can involve everything from SIL study chairing to hazard and operability studies, CHAZOPs, reliability and safety calculations. And in between the consulting opportunities, we do training, and we have developed a suite of online e-learning courses. One final slide before we get into the meat of the topic today, which is the slides themselves that we're going to use today. Many of the slides are extracted from some of our e-learning courses. By their nature, they tend to be animated and narrated. So you'll excuse the fact that I have to narrate them live. In actual fact, if you take an e-learning course, of course, you're sitting there typically with a self-paced course running through it on your own. And one final message: if you stay until the end of the webinar, then you will receive free access to the IEC61511 Edition 2 Update e-learning course. Okay, today's webinar is about IEC61511 Edition 2. I hope that's why you joined, and I hope that's something you'll be able to get something from. Today's topics are going to go through these three areas, and that is an overview of IEC61511 itself. Very, very quick overview, I have to say, because I have to make some assumptions that many of you are here already for that reason. And in that, we'll give a brief history, scope of the standard, and the safety life cycle. Then we'll go on to the meat of the topic, which is the major changes since Edition 1. Obviously, we're in with Edition 2 now, so we'll look at what the changes are, which sections they're in, essentially, and why they've been made. And then finally, we'll finish up with what the changes could mean for you. in the sense that if you're an equipment supplier or a system integrator or an engineering company, or indeed an end user, what those changes will mean to you in terms of impact versus the original standard. A brief history then of where we're at with these standards. If you go back to the 1990s, the HSE published a document called the PES guidelines. Some of you may or may not remember that. I think it was possibly even the 1980s. That was subsequently replaced with the advent of 61508, edition 1. 61508 is the standard on electronic, programmable electronic systems, E/PES. And that essentially became, by default, became a product standard. In other words, a standard that equipment suppliers would validate their systems or products to, with the advent of the 61511 standard, which was aimed mainly at the end use of those products, so the application of the equipment in safety-related applications. You can never fully prize these two standards apart. 61508 and 61511 are interlinked. They use a lot of similar terminology, and the process sector standard, of course, is based upon many of the same principles as 61508. Where we're at today, in 2018 as we are now, is both of those standards have been through their sort of 10-year life cycle, and some minor and some major changes. Most standards are updated every 10 years if they're of an international nature. And where we're at specifically with 61511 is that was republished in 2016 internationally. In the UK, for various reasons which are not completely clear to me, it's only just been adopted as a BS, or a British standard, and that was in December of last year. So December 2017, the 61511 standard is now a British standard, and edition 2 replaces edition 1 completely. I should say at this point, as we're only a few slides in, if anybody wishes to ask questions, please use the questions feature. I will answer questions at the end rather than trying to deal with them all the way through, because it's already multitasking enough for me. But use the questions feature, which is in your control panel. If you press the red button, arrow button, that'll open the control panel, and you can pose any question. You can ask questions anytime you like through the presentation if something comes up in your mind, but they won't get answered until the end. So what's the major changes from edition 1 to edition 2? This is a helicopter view, very much a helicopter view of the major changes. So part 1 is the normative part, the part that we have to try and conform with if we want to claim conformance. And they've trimmed it a little bit, mainly through the rewrite of the software section. Parts 2 and part 3, which are application guidelines, they are not normative. You don't have to follow them to the letter like you do part 1, but they've significantly grown. I think on the basis that there's been a lot of learning about the standard over the 10 years, they've significantly increased the size of those guideline sections. So parts 2 and 3 are significantly more, give significantly more background than before. I'm going to get into some more interesting slides, I hope, in a moment. But before that, I would like to run a quick poll. Now, the idea of a poll is I get the chance to stop talking for a second or two, and you get the chance to see a question come up on the screen. I'm just going to see how I can launch that. So you should be seeing now a question on the screen, and the question is really just as a bit of feedback for myself. How familiar are you with the original IEC61511 standard? Bearing in mind, I don't know everybody that's on the call. Some of you will be at the expert level. Some of you won't know it at all. Some of you will have some familiarity. And it's really just a quick feedback for myself to see how many experts versus how many newbies we've got on the line. Okay, I'm going to close that in a second. So if you haven't voted already, please do so. I've got 80-something% of people have voted. So a few of you haven't voted. I'd appreciate it if you could. I'm going to close it anytime now. Got a couple more seconds. And here we go. We're going to close it now. Thank you. There we go. You can see the results of the poll there. So the number of people online, there's a significant percentage of you have done some projects. Some of you got some familiarity. A few of you are experts, which is great. And there's a couple, there's 10% roughly, which are new to the subject. Bearing in mind that some of you are, many of you are already familiar with it, I'll keep this fairly quick. Is process industry applications. We're talking oil and gas, chemical, pulp and paper, power generation, etc. When we look at the standard, we'll realize that safety instrumented systems are one of many potential independent protection layers that can be applied. So the scope of the standard hasn't changed. It's exactly the same as before. Edition 2 doesn't change anything in terms of scope, but it has altered in some of the detail. Let's not forget it's all about risk. Safety instrumented systems are one methodology we use to apply an independent protection layer to reduce risk. So we try and lower the risk. We can't necessarily lower it to zero. We try and lower the risk of hazardous events like human error and equipment failure occurring by applying independent protection layers. And the key word there is the independent part. The idea is that you don't create protection layers which have common cause failure. So we can apply an operator response to an alarm, we can apply a control system trip, we can apply an SIS itself, and we hope that the building of those independent protection layers outweighs the hazardous events. That's it in a very simplistic view. In perhaps a more technical view, those of you who have worked on SIS projects will realize that reduction of risk and SIL itself, the safety integrity level that we apply, is about factors of risk reduction. So often we talk about probabilities of failure, but we also talk about risk reduction factors. And this is just an example from one of our e-learning courses that shows 3 broad areas of risk related to frequency of undesired events. And the 3 areas are red, orange, or amber and green. If you try and measure the frequency of a hazard, often we'll call that the unmitigated event frequency. And here's just one example. If you start with an event which occurs once in 500 years, which doesn't sound very frequent, that's actually 2 × 10⁻³ per year. And we call that a low demand mode application. It's much less frequent than 1 demand per year. So if we apply some of those protection layers, as we just mentioned on the previous slide, the simplistic slide, if we apply a SIL1 protection layer, which is a safety instrumented system with a certain level of integrity, then that's a factor of between 10 and 100 times risk reduction. Now, the reason for the band is there are bands of probability to give some leeway to the way in which a system can be designed. It doesn't have to be designed in a specific way to achieve the integrity, but it has to be within those bounds. And by that, its very nature, we should have a target event frequency, the target being the frequency that we'd like to reduce the risk to become tolerable. And if the 100 times risk reduction at the top end of SIL 1 doesn't achieve the target, then of course you have to go to the next level of integrity, which would be a SIL 2 system, and so on to SIL 3. Now, in practice, to explain this slide for anybody who's never dealt with this kind of thing before, would take a little bit longer than the few seconds that I have today. However, if you would like to learn more about that in detail, then there are e-learning courses available, and of course face-to-face courses as well. The safety life cycle then is something that those of you who've worked with the standard will be familiar with. If you haven't, then it's a life cycle that explains everything from, if you like, gives a structure to a safety instrument-ready system. So everything from hazard and risk assessment through protection layer analysis, writing safety requirements, and designing the system. Installing, commissioning it, operating and maintaining it, etc. The idea of the safety life cycle is to provide some level of structure. In practice, of course, most life cycles aren't quite as linear and straightforward as this one looks. In practice, applying it can be quite tricky. In the sense of edition 2 of the standard, the safety life cycle itself is mostly unchanged. It hasn't changed in structure, but of course there are details involved in there in terms of competence requirements. Cybersecurity assessment has been added, and that's a field which is fast changing, as we know. And there's some detailed technical changes, some of which we'll introduce today during the webinar. What's still not defined, I think what's not said in the life cycle and in the standard is almost as important as what is said. The number one question I seem to get during functional safety assessments is who's responsible for this? The standard doesn't define that. It doesn't define responsibilities. It's up to you, your organization, to define who is responsible for which activity in a project, whether it's a greenfield project or an upgrade project, or let's say you're just talking about the operations and maintenance of an existing legacy system. The who does what part of the life cycle is actually called management of functional safety. And so the standards don't define that. They don't define what techniques to use. They don't say you shall use HAZOP or LOPA for specific or other specific techniques. And the other thing they don't define is equipment certification. So the standard has never been a certification standard, and it still isn't. If you search for the word certification in the 61511 standard, it doesn't exist, and nor does it in 61508. Now, there are many reputable certification companies, but in practice, of course, the application is critical. Certification is one way of demonstrating that you've done some form of assessment, but certification itself is not a requirement. So that hasn't changed. So we've covered a brief overview of the history of the standard and the scope. We've introduced what the safety life cycle is, albeit extremely quickly. And I hope that you will forgive me for not being able to do much more detail on that at this stage. So what are the major changes from edition 1 to edition 2? I'm going to cover them really pretty much in the same order as the life cycle. It seems the most obvious way to do it. So we'll start with management of functional safety. What has changed? Well, as you can see on the screen there, competency was always a part of the standard, but it was never really very mandatory that you had to demonstrate competency. So now it's become a shall requirement. You shall address it. And the reason for that is this is quite a technical standard, and applying it is not necessarily trivial. At least in my opinion, it's not. And so it very much relies upon having competent people who are familiar with the way the standard works and with its requirements, and with being able to justify certain elements. So you're required now to have a procedure for competency management. And that really applies across the board. It doesn't matter whether you're a supplier, an end user, an engineering company, you should have competency addressed. So if people are responsible for a part of the life cycle, then their competency with respect to that part of the life cycle has to be assessed. There's a specific new standard, requirement in the standard for suppliers making functional safety claims, that they must have a functional safety management system. FSM on my slide here means functional safety management. So if you're a supplier and you're making SIL 2 or SIL 3 claims for your product, you really ought to be addressing that, because it's not a nice to have, it's a mandatory requirement. The second part of management is functional safety assessment is now required periodically during the operation and maintenance phase. So if you're an end user and you're operating even existing safety instrumented systems, you can't any longer say, well, they were designed before 61511 came out, or these things don't apply because it's a legacy system. They absolutely do apply in some sense. And so you are required to carry out assessment of those systems. Now, what does that mean in practice? That could be a whole webinar on its own. In fact, it will be fairly soon. I'll be doing a webinar on what does a functional safety assessment mean for an end user with a legacy system. If you'd like to join that, then the details will be at the end on how to join that. So functional safety assessments required periodically during operations and maintenance. That's a new requirement. That never used to be in the original version of the standard. It used to be literally if you were changing or modifying or updating a system, then you would have to do one, but now it's required. Procedures used for safety lifecycle have to be subject to audit. You can do an audit along with an FSA. And there's a fully updated application program lifecycle. So application program is the new word for software. I'm not quite sure why they changed it. I guess just to distinguish it from software that's embedded inside systems. So we're really talking about the software that you would use, or the application level software that you would use, like function block diagram or ladder logic. Those types of software have a new life cycle and verification criteria, testing criteria. So moving on from management to the process hazard and risk assessment stage, the big change is this new requirement for security risk assessment. So although this is a safety standard, of course, the reality is that we're dealing with many types of control system, programmable system. So whether it's the basic process control system or the safety instrumented system, in fact, both typically have to be combined in one set of a security risk assessment It's now a requirement of 61511 to assess the risk posed by cyber threats. So it starts with a risk assessment. Of course, then following a risk assessment, you're going to want to probably do some things to change the threat level from one level to another. So this is new in the standard. My understanding of, at least in the UK, with the Health and Safety Executive, they have published one guideline already on this, and I believe from going to a conference in November last year, so within the last few months, an HSE representative suggested they will be starting to ask end users what they're doing about cybersecurity with respect to control and safety systems on your plant. So that's a new part of the standard and something you should be aware of. The second part of hazard and risk assessment, H&RA, is what that stands for, hazard and risk assessment, is if you have a high risk reduction requirement. So if you use some form of risk analysis like a risk graph or risk matrix or even LOPA, and that comes out with requirements where the SIS or the SIS in combination with the BPCS, with the basic process control system, if they're coming out with SIL 4 plus type requirements, then there's now a shall requirement to review. In other words, you can't just carry on and go and try and develop a SIL 4 system, not that that would be a good idea anyway. So there's a requirement for review. Of course, you can't specify exactly what would have to change, but it could be a process design change, could be inherent safety would have to be thought through. It could be the application of other IPLs that haven't already been thought about. But you can't plow on regardless and try and engineer a SIL 4 system. That's not allowed within the standard anymore. Some detail that's changed with regard to protection layers. Again, this is one of the slides from our e-learning course. Let's say you were trying to apply LOPA. I don't know how familiar the topic of layer of protection analysis will be with everybody that's on the line. But in layer of protection analysis, of course, you're analyzing the independence of protection layers. One possible protection layer would be a basic process control system, BPCS. Another one might be your actual SIS. Now, it's fairly clear already from the standard that those have to be independent. So they, as the picture depicts here, it's expected that the sensor, input modules, processing, output modules, final elements, all those elements within the function are independent between the layers. So your BPCS and your SIS don't share anything if you want to claim independence. So the LOPA rules for that are unchanged, really. Independence is still required. If you want to claim independence, then they have to have separate elements. What possibly has changed is the rules for the BPCS itself, and now it's recognized in some cases companies would like to, they have the opportunity to have another BPCS loop to claim as a trip. Now, you can only do that if you can meet certain criteria. So in this case, the idea of they've got two different BPCS loops here. Now, you can claim one layer, so one trip, if you like, BPCS trip, if that is fully independent of the initiating source. So if the BPCS loop on the top there, for instance, is the initiating source or the initiating event, of course, that can't also be a protection layer because it's the initiating event, and that's unchanged. But if you want to claim another layer, another BPCS, that is allowed, provided it's completely and fully independent. And that means the logic solver, as well as the sensors and final elements, etc. And you're also limited to one. So the standard is now tightened up in a way to limit you to one claim. So you can only have one BPCS layer if there is another BPCS as the initiating event source. And the final example here is where some companies would like to try and claim two BPCS loops. And the standard has now said you can do that. However, they can't be the initiating event. So neither of them can be the source of the initiating event. The initiating event would have to be something outside of a control system failure. They have to be fully independent if you want to claim two layers, and you're limited to two. So you couldn't go beyond and add a third one or a fourth one or anything like that, because now the standard says that's not allowed. You're only allowed up to two BPCS IPLs and meet the full criteria. So that's a tightening up in the standard of some rules which were possibly unclear before. There were various guidances out there, but now it's written in the standard, and hopefully that will be clear to anyone who's trying to engineer systems for the future. We're skipping pole 3 for the same reason as before. I don't want to get hung up on it. And we'll go straight to the next part of the standard that's changed, which is the safety requirement specification. The requirement for an SRS has not changed. It's still the same as ever. It's a critical part of the standard, and it's super important to get it right. So what has changed is there's a tightening up. There's some extra things that you're required to think about. One of them is proof testing. How are you going to proof test? That should be clear at the SRS stage. So if your SRS doesn't contain any idea about how the proof testing is going to happen, then really it's a deficient SRS. It's not meeting the new standard. Process safety time we could talk about a lot. I'm not going to try and define that here, but that's something that must be considered. Leakage rate for valves as final elements, written procedures to be applied during bypass state. All of these extra things should be thought about at the SRS stage. If you want a detailed list, I should give the IEC a bit of publicizing here and say by the standard. I can't copy it to you, so it's a copyright standard. You would have to buy the standard itself to get the detail. However, the SRS hasn't really massively changed. There are some extra bits. The ones that I would highlight would be process safety time. That has to be very, very clearly specified. And also the final one there, the final bullet, logic solver application program. Your software should have a detailed specification. It doesn't necessarily have to be contained in one document. It could be in multiple documents, but there has to be a much more detailed level of software description. Moving on to the next thing that's changed in terms of through the life cycle, we're into hardware now. If you're designing hardware, if you're selecting equipment from manufacturers, then a safety manual is now a requirement for all SIS equipment. I have to say, on working on several projects in the last few years, I can say that there's still a very, very variable level of safety manuals. So we're talking about functional safety here, not just operations and maintenance manuals, but functional safety manuals. They vary fairly wildly from supplier to supplier. So that's an area that could be significantly improved. The hardware fault tolerance rules, I apologize if you don't know what that is, but it essentially relates to the amount of redundancy you have to build in for safety purposes. They have been aligned to 61508. That should say edition 2, so not the original 61508, but the latest one that was published in 2010. What that essentially means is we now have agreement of the two standards, and you can follow the hardware fault tolerance rules in 61511 or 61508 edition 2. You shouldn't go back to the earlier standards, which are now replaced by the latest ones. There's a new requirement to have credible and traceable failure rates. So if you're doing PFD or PFH calculations to calculate the probability of failure of your safety functions to see if they achieve the required SIL, then they have to be both credible and traceable. Now, of course, we all know that is not necessarily a trivial exercise. However, that's what the new standard says. And finally, SIS security resilience has to be thought about. And so that's something new that, if you like, matches or marries up with the requirement to do some assessment of security of the system, cybersecurity. In software terms, we can't do it justice in a short webinar today, but there's been a complete rewrite of the software section of the standard. You're required to separate safety and non-safety code, to have safety outputs in a process safe state on PowerUp, to exercise the entire application program every scan. And there are some new requirements for validation or information for validating the system to an integrator, and information given to the end user. So there is very much a new emphasis on software in the standard, on application programs and how they're developed. And so if you don't already have access to the standard, you should get it. Certainly if you're a system integrator writing or coding software, then that's something you should be familiar with. Cannot any longer use the original 61511 to follow that software section, because it is completely different. It's essentially throw it out and start from scratch. It's a brand new section. So unlike a lot of the rest of the standard, which is relatively small tweaks here and there, this section is completely new. So getting through the life cycle now, we're at the FAT, installation, commissioning, validation, testing stage. If I can specify one thing on here, it's planning, planning, planning. The validation itself is only going to be as good as the test. So FAT, as you see there, is no longer an informative part of the standard. I think in the original version, it kind of gave the option that you might not have to do FAT. Now that doesn't exist anymore. FAT is a requirement, but validation, of course, is a requirement. That's the site validation. And if your procedures for validation and your planning for validation is not very good, it's likely that validation itself will not be very good. And so that's a fairly beefed up section of the standard to improve the validation planning. I'm going to speed up slightly because we're probably running out of time. I think we've got about 10 minutes or so, 13 minutes left. So I'm going to go through these fairly quickly. I know there's a lot of points here, but you will get access to this presentation afterwards, so please don't think you have to read everything now. Operation and maintenance. So we're into the operation and maintenance stage of the life cycle. Of course, this is the longest part of the life cycle. In my view, the most important. And in reality, the operation and maintenance requirements have just been I'd say improved from a perspective of made more robust. Now, whether you call that an improvement if you're an end user or not, I don't know, but they are more robust. It's a requirement to, for instance, plan how you're going to respond to faults and failures. It's a requirement to now collect demand rate data. So if you have a demand on a system, then that has to be logged. It's a requirement to have a bypass log if you do have the possibility for bypass. It's a requirement to have compensating measures written out during the bypass time. And so really there are quite a lot of things that have altered, and there's a second slide here that really make this a more robust standard in terms of the requirements on end users to operate and to maintain systems. I'll point out one thing on this second slide, which is that modifications now, the definition has been more clearly and overtly specified than in the original standard. And so now they say, okay, modification includes if you change the proof test interval, if you change a procedure, if you change a set point, if you change an operating procedure, etc. So instead of just leaving it to you to decide what a modification might be, all of those things would require you to go through some management of change process. And I think, again, that's more robust in terms of a definition than the original. I'm going to finish with just a couple of slides now. So we're very near the end, and we should have a good few minutes for questions. What the changes mean for you. So we've been through an overview of 61511 very quickly. We've been through the major changes, and now finally what the changes could mean for you. And I apologize, I don't know what everybody does who's on the line. If you're an equipment supplier, you must develop a functional safety management system if you don't already have one. Now, of course, if you don't provide any equipment for safety instrumented systems, then that doesn't apply. But if you're making any SIL claim about products and selling those to end users as SIL capable products, then you've got to have a functional safety management system. If you don't know what one of those is, then engage somebody who does, and hopefully they can help you through the process. Assess and document competence of people designing and developing SIS related products. In other words, that would be part of your FSM, your functional safety management system. And more overtly, what you should do is update any product assessments. So I'm working on several projects, as I said at the start, at the moment, where equipment has been selected. Some of it doesn't have any formal assessment or certification, even though it's being used in a safety duty. Some of them, in fact, many of the equipment items that are being used in a relatively new project have what I would call dubious certification, dubious in that it's outdated. So if you assess something to the original 61508 edition 1, the assessment may no longer be valid if it's because the edition 2 came out in 2010, which is already 7 years ago. And so you've had sufficient time, I would say, to have updated that and to make sure your assessment, whether you call that a certification or not, your assessment should be to the latest standard, not to the old one. If you're a system integrator or an engineering company, likewise, you must develop an FSM system if you don't already have one. That will involve documenting and competence. You should also ensure that people learn the latest hardware fault tolerance rules if you're designing systems, so the hardware side of things. And if you're designing systems which involve application programs, software, safety logic solvers, then you should ensure that the people involved in that design are aware of the completely new requirements in addition to on application programming. And last but certainly not least, the end user operator. A slightly different list here. I'm making an assumption that an end user operator will have some kind of functional safety management system, but of course that may not be the case. If you don't, then the same thing would apply. Part of that will be assessing and documenting competence of people who work with whatever stage it is, the HAZOP and LOPA, the specification, designing and testing systems, if you do that in-house. If you don't do it in-house and you buy that service in, making sure those people are competent. And then, of course, in your operations and maintenance overall, having people that are familiar with the latest requirements, such as the IPL requirements for LOPA, operation and maintenance procedures for the SIS, and very finally, the last point, because of the change in the emphasis of the standard on functional safety assessment, you must conduct a functional safety assessment periodically. The standard doesn't say how often. My suggestion would be every 2 years. It could be every 5 years. That's your choice, really. But if you haven't conducted one in the last few years, then my suggestion would be that you schedule one, and you can do that at the same time as doing an audit of your procedures.